Hey guys, I came across this problem and I wanted to share how you might solve this. It's an indeterminate form and you'll need to use L'Hopital even though it's not in a standard form like 0 over 0 or infinity over infinity. So to solve this, you might first consider trying direct substitution. But you run into 1 over 0, which is bad. So you take a step back and you look at this exponent. So in the numerator we have x, and that we know goes to 1, and the denominator goes to 0. So if you imagine this as the graph of x over x squared minus 1, you have a horizontal asymptote at x equals 1. So as x goes to 1, x over x squared minus 1 goes to plus or minus infinity. So that's the exponents part. What about the base? Well, that just goes to 1. So we know that the base goes to 1 and the exponent goes to plus or minus infinity. Where else have we seen this? Well, you might be familiar with e, which is the limit as n goes to infinity of 1 plus 1 over n raised to the n, where we have this base that goes to 1 and this exponent that goes to infinity. So we might reformulate this exponent in terms of e. So limit as x goes to 1, we use e as our base, x times natural log of x over x squared minus 1. And the good part about this is that e to the x is a continuous function, which means we can take this limit inside our exponential. Rewriting that gives us e to the limit as x goes to 1 of x natural log x over x squared minus 1. And this is a standard limit. It's your 0 over 0 case. So, and we've already shown that it's indeterminate. And so now we can try L'Hopital's. The derivative of x is 1 times natural log of x is natural log x. And then the derivative of natural log of x is 1 over x times x is 1 over the derivative of x squared minus 1 is 2x. And if you evaluate this at 1, natural log of 1 is 0, 2 times 1 is 2, and you end up with 1/2. Plugging this back in, we get e to the 1/2, or in other words, the square root of e.